Students, welcome to class 9 subject mathematics, and today's topic is Euclid's geometry. So first we will see one theorem. So I'm writing the statement of the theorem. Two distinct lines cannot have more than one point in common. So now how do you solve this? Two distinct lines, suppose we have two lines L and M. Two lines we have L and M, and they cannot have more than one point in common. If these are two distinct lines, so what is given here? L and M are two distinct lines. And what we have to prove? To prove L and M contain at most one point in one point in common. Now how do you prove? Or you can say this one, that two line L and M will intersect only at one point. This is the to prove part. Then now we have to write proof. So we will apply here contradiction method. So what is the given theorem statement? Look at once more. Two distinct lines cannot have more than one point in common. So when we will apply contradiction method, so that time we have to assume that two distinct lines have one point or cannot have more than one point. So we will write they have more than one point in common. That means 2 points. So suppose L and M, two lines, have two distinct points, A and B in common. So we have to assume the opposite of the given statement. This is the contradiction method. Now if L and M, two lines, they have intersected in 2 points, that means we can write here that we know, so it means thus L contains both the points A and B. Again M also contains both the points A and B, but we know through 2 points, only one line can pass through. But here L and M both passing through A and B. So this is the contradiction. So therefore this is the contradiction. And why does this contradiction occur? Because of our assumption. So this contradiction occurred because of our assumption. So therefore our assumption is wrong. Our assumption is wrong. So therefore whatever it was given in the given statement, so that is true. So we have to write that two distinct lines cannot have more than one point in common. So before going to in theorem 2, we have to know one axiom that is known as parallel axiom. And students, we already discussed about axiom and postulate. Axioms are obvious fact which is taken as true without any proof. So in parallel axiom, what it's telling, if L is a line and P is a point, not on the line L, so there is one and only one line which passes through P and is parallel to L. So this is known as parallel axiom, and we can say this statement, this axiom in a single line, that two intersecting lines both cannot be parallel to the same line. So this is Playfair's axiom, known as also Playfair's axiom. Now we will see our second theorem. So students, can you say about the theorem? Theorem is a statement which we are proving by logical statements. And what is statement? Statement is those group of meaningful words which giving something as a true or false. So that taken as a theorem statement. So now we will see theorem number 2, which telling about two lines which are. So theorem 2 statement is two lines which are both parallel to the same line are parallel to each other. So given, so how do you prove this one? So first read once again, two lines which are both parallel to the same line are parallel to each other. So suppose one line is there, that is L, which is parallel to M, and another line is N, which one is also parallel to L. So this is L, which is parallel to M, and this is N, which is parallel to M. So what is given here? L is parallel to M and N is parallel to M. Now we have to prove, that means to prove L parallel to N. So these two, first one and second one, will be parallel. First one is parallel to M, second one is also parallel to M. So we have to prove first and second one parallel to each other. So how do you prove this one? So to prove is written, then we have to write proof. So here also we will apply the contradiction method. So what it's telling us, that suppose L and M both are not parallel. L, M, what we have to prove? We have to prove L and L are parallel. So this one we have to prove. So we will assume that suppose L and N are not parallel. Not parallel means they will intersect somewhere at a point. So then L and should intersect in a unique point, say P, in a unique point, say P. Now we already know in our parallel axiom, if L is a line and one point outside of this line P, so there will be only one line through that point which will be parallel to that given line. So this one now we will apply here. So if P is the point, so through P only one line will be there. So by parallel axiom, we can say that through P there will be one line which will be parallel to, so outside L. By parallel axiom we can say that outside N, outside M, outside M there is a point P where L and both are parallel to M. Which is parallel to L, but here L and M, L and N both are parallel to L and N both are parallel to M. So which gives us the contradiction. So our assumption is wrong. So therefore L is parallel to M. L is parallel to N. We assume here L is not parallel to N. So that for that assumption this contradiction occur. So now we have to say that L is parallel to N. So thank you students. Have a nice day.